Good morning. Lost track of time there for a minute. Just getting ready and excited for today's lecture. Welcome, everybody. Okay, Jada, so I forgot to mention... Good morning, Jada. How's softball going? So question 2 and 3 have multiple answers. I totally did not write that down in the quiz for some odd, obscure reason. And that was not indicated to you naturally by UB Learns. I will mention that. Louisiana? You guys went all the way to Louisiana? Do you guys fly? I hope so. Do you fly? Morning, Joey. Morning, JR. Okay, good. Whew. I can't imagine driving all the way to Louisiana for a weekend. Good Lord. Anyway. I hope it's fun. I hope you guys have a good bonding experience this semester, or this season, I guess, as you, really, based on your schedule, it looks like you're not allowed to interact with anybody other than those on the softball team. JR, what do you mean by funny moment? Like, you were so exhausted and so overwhelmed that it was just funny in the sense that there must be something different? Or was it legitimately comical? Anyway, once again, I'm sorry. Someone emailed me or messaged me the light bulb. The light bulb's amazing. There's a lot of light bulb moments when it comes to programming and apparently taking quizzes. Yeah. If you notice on UB Learns, there's like the circles, and then for multiple answers, it makes them like a square. That's like the only indicator. Once again, I forgot to write more than one answer. And it was not clear in the which one. I don't know. I'm sorry. My fault. But there are more than one answer for question 2 and question 3. Let's see. There are 404 responses and 84 people submitted. Ooh, that's an average of 4.5 times everybody submitted. Also, when you guys take the quiz, you don't need to write your feedback for every single response. I can download all of your guys' answers. So a lot of you guys just copy and paste or have to retype all of your feedback. Don't worry about it. Type it in once and then ignore those questions. Once again, I will mention this also during normal, like when we get to lecture time. But good morning, everybody. I hope you guys had a good weekend. Productive weekend. I was thinking this weekend myself that it would be really nice to have spring break. But once again, we will just continue to mourn the loss of spring break and move together 1 week at a time. 1 week at a time. Welcome to week 5! Week 5! This is the end of this week as a third of the way through the semester. Hopefully, you guys have this sense of, I can do this and I can succeed, versus, oh good lord, it's only a third of the way through the semester. I'm going to die. I appreciated all of your guys' feedback in terms of what is useful, what is helpful, what to change. It sounds like the mechanisms set in place seem to be working. Once again, this is the best, like, submission, response, feedback. I mean, I definitely feel like I've gotten much more feedback from you guys this semester versus last semester's, previous semesters when they're in person. So I really appreciated that. Keep giving me feedback. Let me know what can be changed, what can be altered. Most people didn't mention anything about office hours. Let me know how office hours are going. I've gotten some feedback in the sense of sitting in the waiting room forever, not knowing when you're going to be let in. So let me know, just let me know anything within reason. I'm not going to just give you guys answers, but anything that you guys need, want, that can be helpful. Matt, yes, it was very short Zybooks for this week, partially because of the material. Next week will also be kind of long. But, I mean, you only have Zybooks material for the next we're on chapter 6 this week. 7, 8, and then 9 is, like, really short. And other than that, then you will not have to do Zybooks anymore. You can always look at it as a reference. But then we will transition to the project, which, I don't know, it'll be fun. It'll be exciting. So, let's go ahead and get started. Question 2 on the comprehension quiz. I'm not going to go over the quiz. Come on, computer. I'm not going to go over the quiz now because you can go back to it after we review the content. Just because it's stuff we're going to go over today and on Wednesday. So JR, interestingly, a lot of people said that they appreciated Zybooks. I mean, liking is relative, but a lot of people said that the textbook was actually pretty helpful for them. It's fine if it's not helpful for you. Everybody learns differently. And honestly, a lot of your assignments are repetition. So you get the content from me in lecture. You get the content from your textbooks in a slightly different way. And then it's practice. So you practice on the homework, you practice in the challenge activities, you practice in the participation activities. So it's just repetition. If some people aren't really learning much from lecture. Some people found the Friday videos helpful. Some people didn't mention those at all. Some people mentioned the notes. Some people, everybody learns differently. If the textbook isn't really the way that you are learning, that's fine. I mean, you still need to do the assignments. Think about it as just repetition. How are you reinforcing the material? When it comes to programming, a lot of it is repetition. It's not necessarily memorizing a formula. It's just trying different things, trying different ways. And you gotta use it or you lose it. And it's not you're losing it per se, but if you're not using it, then you kind of forget about it. And with programming, the more you use it, the better you get at it, the more you practice it in general. Interestingly enough, I thought the same thing, Ronald. Textbooks usually aren't useful. Like, I was reading your guys' responses, and I was just impressed with how many people said that the textbook was useful. And I know the textbook was $70 for you guys, but hopefully it's a more useful textbook than others. Okay, let me go ahead and start lecture. Let me start the lecture. Okay. So a couple things to review. So first thing first, the homework solutions are posted on UB Learns now. If you go into, homework 1 was posted a while ago. But if you go into UB Learns under week by week content, you can see here that what I'm going to do is I'm going to post the links to the homework solutions directly on that page so you guys can directly see it. So a lot of you guys had questions on, or some of you, well, not yet, had question on homework 3 corners. So if you just go to the solution, a lot of you guys probably would be interested in the solution for homework 3. You guys can pull it up. You can see how I did things, because I wrote these solutions, even though it says instructors. I wrote the solutions. You may have done it differently. We are getting to the point where there's lots of stuff, lots of ways to do problems. So just because you see it one way on the solution does not mean that the way that you did it is incorrect per se, but use it as a guide to help you understand the material a little bit more. So here is problem 1, problem 2. Here is the corners one for problem 3. You can see the equations in order to do things. There's lots of ways to do things when it comes to indexing, as we talked about last week. But here you can see how I did the solution, and these might help you understand a little bit more about how to do array indexing. Okay, so that's first things first. Let's get back to the notes. So some of you guys still mentioned you're confused with arrays, and once again, you just need to practice. You just need to see examples, do things. You will continue to see us use arrays throughout the semester, so hopefully as we move through the material, it becomes clearer, it makes a little more sense. If you're still struggling, come to office hours, try and get more help. But essentially, we're looking at the left-hand side and the right-hand side, asking, where are we going to store things on our left-hand side? Is it an entire array? Is it part of an array? Which rows? Which columns? You can do more than one row and one column at a time, sorry. And then on the right-hand side, what to store there. So I know I'm just reiterating what I talked about, but you'll get more exposure, more examples. Make sure you're constantly trying to understand everything that's written down by going back, going to office hours, and continually asking yourself these questions. What's the left-hand side? What's the right-hand side? Okay, so a little short review of the material from last week. So a lot of you guys asked questions about the inverse. So here is our equation for finding the inverse of a matrix. A inverse equals 1 over the determinant of A times A adjoint. For a 2 by 2 matrix, this essentially is your formula. If A looks like this, A, B, C, D. The determinant is AD minus CB. You draw that little fish. And then the adjoint matrix is A and D switch places and B and C change their sign. So this essentially is your equation for a 2 by 2. If you are doing more than a 2 by 2, if you're doing 3 by 3 and above, don't worry about doing it by hand. I know your textbook had it in there by hand. We will get to 3 by 3s and bigger by hand after the midterm. So for now, just use MATLAB. MATLAB has the I and V function, or you can type it like this. There's 2 ways to type it in MATLAB. So a lot of you guys mentioned that in the quiz. I don't know how to do 3 by 3s, or 3 by 3s are hard. Don't worry about doing them by hand right now. They were in the textbook, but it's the participation activities, so you can't get those questions wrong. So just continue clicking through. I did mention that last week in lecture, so I did, because someone asked. Yep, that's fine. So here's how you would do it in MATLAB. A lot of you guys also asked when to use linear algebra notation, so the regular asterisk, that caret, or that divide, versus element by element operations, this dot, asterisk, dot, caret, dot, divide. In general, for this class, unless you are explicitly doing linear algebra operations by double checking your work or solving systems equations, you're probably doing this instead. Okay, so if you are solving systems equations, this is what it looks like. You write it in the form of AX equals B on paper. And then in MATLAB, you plug in A. You figure out what A should be. You figure out what B is, or type in B, type in A, and then this is what you type. A, or X equals A left divide B. That is an explicit linear algebra operation. That is going to be the case when you're solving systems equations every single time. If you're not solving systems equations, then most of the time you're doing element by element operations. So here's where it's important to understand, what are you trying to do on paper? On paper, would you be doing linear algebra calculations, or on paper, would you be doing lots of the same calculation with every element? So element by element operations, like I said, it's most of the time you put that dot in front. And I mentioned this last week, but first, write your expression as if it was scalars. Just like we did in week 1. And then go through and add your dot in front of all multiplication signs, all caret signs, and all division signs. Wrong one. So most of the time, if it's not explicitly linear algebra on paper, so if you would do the operation on paper using linear algebra, use these. If not, for the most part, you're doing element by element operations. So write your expression as if it was a scalar, just like you did in week 1, and then go through and add a period in front of every single multiplication sign, every caret for exponentiation, and every division. Okay. Hold on one second. So for questions, so back to your comprehension quiz, a couple notes. For questions 2 and 3, there's multiple answers. So either 2, 3, or 4 answers are correct. Go back to it after today's lecture, after Wednesday's lecture. Also, one thing to mention about the comprehension quiz is for those last 2, or for that last question, you only really need to give me feedback once. You don't need to keep typing it every time you try the quiz. I can download all of your submissions, so just type it once. You don't need to repeat it over and over and over again. It's fine if you do, but just for your sake, you don't need to. Joey, there is no formula to memorize for matrix multiplication because you always have different size matrices. So you just need to go through examples, look at the steps over and over and over again. In the notes, there's a generic form for matrix multiplication where you can see all the dot products over and over and over again. But it's just practice. If going through the homework, you don't feel like you've had enough practice, create matrices on MATLAB or write down your own matrices and check your work on MATLAB, or go to online and find examples there, or go to your textbook. Your textbook should have more examples as well. Okay, let's go ahead and get into our new material. So, yeah, for number 2, and for the quiz, you can always copy and paste stuff into MATLAB as well. These quizzes are not in a box. I'm trying to write them so that it makes you guys think, and just test your knowledge and how you understand things. Okay, let's go ahead and begin. Like I said, the quiz. We will talk over the material today, and on Wednesday, go back, revisit it. Okay, let us begin. So this week, we are really talking about 5 main functions: input, disp, fprintf, and then load and save, which are very similar. So I'm going to go over those 5 questions, specifically looking at examples from last year's homework. Hopefully it helps clarify some things. I'll step through the thought process of how you choose which ones to use, when, and what they look like. Okay, so first thing first, let's say we have something that says prompt the user. Prompt the user. Prompt the user. Whenever you see that, or prompt whatever, any combination of this from the user, it means use the input function. Someone mentioned, when do we use the difference between input and disp? Disp is to just display. Input is to prompt the user. So prompt the user means use the input function. to input the following variables from the command window using the specified prompt. So there are two ways to use the input function. A equals input some text followed by nothing. That's my first way. Or my second way is to type input, prompt, and then follow it by an S. These are my two ways to use input. This is how it's listed in the notes. Over here is my variable I'm going to store my data in. So this data that it stores is going to be from the user. So whatever the user types in, that's where it's going to be stored, in this variable that shows up on my left-hand side. Then I have my input function. The input function, the way it operates, is it is going to print out this text. Specifically to the command window. And then it's going to pause and wait. It's going to pause and wait until the user enters in some data. That data is entered in using any valid MATLAB way. And then once that the user enters in, once they press enter, it's going to be stored in this variable. And that's it. That's how the input function works. It's equivalent to cin with C++, to scanf with C. What was it for Java? Scanner. The scanner class for Java. I don't know what it is for Python. But it's essentially how do we get input from the user on the fly. And like I said, there are two ways to use input. This is the way you would use it if you expect numerical data. And here's what you would expect for text data. Notice I have these single quotes in here. Single quotes indicate we are talking about what's called a character array or a string array. So we use single quotes for most things in MATLAB. You can also use double quotes, but that is treated differently. Single quotes is a character array. It's essentially an array of characters. Single quotes is a string scalar where it's just a single value. So most of the time you will see me use single quotes because that's the way that I'm used to typing text in MATLAB. Double quotes were introduced in 2017 version of MATLAB. And so I encourage you to use single quotes because you will run into less problems, although I think you guys should be fine using either for what we're doing in this class. Okay, so let's go ahead and see. So let's go ahead and type this into MATLAB, and we will run it line by line, and we will see what happens to answer your question. I think that'll answer your question, Joey. Okay, so I've got my text up at the top and MATLAB here. If you guys ever can't see anything, please just let me know. I can change the font size. Okay, so prompt the user to input the following variables from the command window using the specified prompt. So I have 4 things I want to ask the user for. I want to ask the user for the type of fluid, the density, the velocity, and the diameter ratio. These variables correspond to a specific equation down here. This first one, the type of the fluid, is just a generic kind. This type of fluid might be water, might be gasoline, or other types of fluid, whatever it might be. Okay, so first things first, let's prompt the user to enter in the type of fluid. Okay, so I'm using the input function. The input function, I type input, open close parentheses. I have 2 ways to use it. I can either use it this way, this A way, or the B way. The A way is if I'm expecting numerical data. The B way is if I'm expecting text data. If my type of fluid is water or gasoline, that means that I am expecting text. So I'm going to use this option to ask the user for what type of fluid. Okay, so I do input, single quotes, prompt the user with the prompt, which says enter in the type of fluid. And then I need my S because I am expecting text. And then identifying what variable do I want to store that in. I can name my variable whatever I want. I will call it type. There we go. That's the first thing. Follow with the semicolon. Now is where you put a semicolon everywhere. All of the wheres. Every single line of code should have a semicolon. So, prompt the user to enter in the type of fluid. I use the input function. Here's my prompt. This will be printed out to the command window. I'm storing whatever the user enters in the variable called type. And then this means I'm expecting text. So anything the user enters in will be stored as text. Okay, so let's see what happens. Let's see what happens when this line of code is executed. So run. Okay. When MATLAB hits the input function, it's going to go over to the command window. It's going to print out that prompt, letter for letter. So it prints out enter in the type of fluid, semicolon, space. See, this is printed out in my command window. And then it pauses. You can see my cursor is here waiting for the user, for me to enter in something. I'm going to enter in something, press enter. And then I hit the end of the script. Whatever I entered in is now stored in the variable called type, and you can see that in my workspace. You can see it's a variable called type. It's a character array or a string array, and it is a 1 by 11 because it has 11 characters. And then it would continue. Did I answer your question, Joey? Okay, let's move on to the next one. So the next one, okay, so I've done this one, check. I've prompted the user for the type of fluid. Now I want to prompt the user for the density. So once again, I'm prompting the user. I use the input function. My prompt is enter in the density, kilograms per meters cubed. Note, I'm putting a space here just because it prints out character by character. If I didn't have the space here, it wouldn't have the space here, which means whatever the user entered in would be right up against that colon. So just sometimes make sure you're aware of everything character by character in this part of our programming. We need to be careful about what we're actually printing out. What do we want it to explicitly look like? Because it's not going to do all those autocorrect for you. It's not going to space everything out for you. You need to be explicit about every single character that you want to print out. Okay, so enter in the density. Note, density, I expect a number. So I'm not using this one. I'm expecting numerical data, so I'm using this one, where it's just the prompt. And then I'm going to store that number in my variable called row, because it represents row on my paper here. Okay, so now I've gotten that one down. Zanzib, you cannot, in the input function, I don't know, let's try. So I'm going to now prompt the user for velocity. Okay, so I'm going to store that in a variable called v, use the input function to prompt the user. My prompt is enter in the velocity, meters per second. Let's see if I can put a new line in here. Okay, so Zanzib mentioned using a \n in order to indicate, at the end, in order to indicate going to the next line. So this is white space character expression. Let's see what happens when I execute my code now, okay? Yes, I did mean CLC. Okay, so run. So now enter in the type of fluid. It's pausing, it's waiting for me to enter in the type of fluid. Water, the density for water, I think is 1 or 1,000, whatever kilograms. And yes, so here I got to enter in the velocity. Zanzib, you can see that I have a new line in here, \n, which means press enter. So it prints out ENTER space IN space THE space VELOCITY space bracket M backslash S bracket colon, and then this is 1 to indicate press enter. So it prints all of that out character by character, gets to that backslash N and presses enter. So you can use backslash N in order to control your white space in input. Velocity, I don't know, 4. And then it stops. Okay, one more thing to input. I've done rho, I've done V. Let's go ahead and enter in R. So R equals input. Enter in the diameter ratio. Personally, I like spaces. You can prefer backslash N, it's up to you. I like spaces, so I will just leave it like that. So the annoying thing about the input function is you have to type everything in as you go along. The example I have is gasoline, 735, 5. You can also enter in anything with valid MATLAB text. So diameter ratio, I'm expecting numbers. I can also enter in an array or a matrix. I could say 0 or 1 to 10. So now my diameter ratio is an array of 1 to 10. Gasoline. I could do a matrix, 1, 2, 3, 4, 5, 6. So now density would be a matrix. So any valid MATLAB code. I could also use linspace. I could use also all of that, all of MATLAB functions as well. So Joey, we would use the input if we are writing a program that asks the user for some data. So like you have a user interface and you, like a calculator. So you have a calculator, you type in 2 numbers, and then you want to do some sort of operation. So you can ask the user, number 1, number 2, what's the operation? That's a very basic example, where you could just run the program and the user, it can interact with the user. It can ask the user, what kind of information do you want to do? Do you want to use? Kind of like when you write functions where you don't know exactly what the inputs are going to be, but you can do the same code, the same operations, regardless of the type of input. Same idea, except for a script file. So it allows us to interact with the user, to ask the user for some information without knowing exactly. Because if you wanted to do some calculations, you have to go back into the script file and manually change what all of these values would be, as opposed to just rerunning the script file and entering new numbers in your command window. It's not as intuitive to use the input function for MATLAB as it is for other programming languages, but we're still covering it. It's not my favorite function, but that's why we use it. Yes, so Tidy MATLAB does have a GUI library that's beyond the scope of this course. But yeah, you can make standalone programs in MATLAB. Okay, so that is using the input function. So now, given these inputs, I can do some calculations. So it says, use the input values to calculate the pressure drop using the formula del P equals 1/2, etc. So, del P equals 1/2 times 1 minus R squared times rho times V squared. Okay, so this is if everything was a scalar. If everything was a scalar, it would look like this. However, what if R was a vector? What if V was a vector? What if rho was a vector? What if all of them were vectors? So I'm going to go ahead and go through and make sure I just vectorize my notation, which means that I'm going to put a period in front of all of my asterisks, in front of my carets, and my division signs. So now I can use element by element operations. So now if R is a vector, I can go ahead and do my calculations. So let's go ahead and run this one more time. Enter in meaningful values. So gasoline, 735, 5 for the velocity, and let's say my diameter ratio. These are my sample values. So now my fluid is gasoline, my density is 735, my velocity is 5, and then my diameter ratio is a vector. So if I look down in my workspace, I can see that row was assigned 735, V was assigned the 5, type was assigned gasoline as text, del P was my calculations, and then R is a vector. So del P is a vector because R is a vector. And I can rerun it with new values as well, and get new numbers. Okay, so I'm going to hard code these values in though, because I don't want to have to keep typing things in, because that's annoying. Oh, wrong one. Okay. So let's just work with these numbers moving forward. Now I don't need to retype everything when I run my code. So let's say these are going to be my inputs. I can do my calculations. That is the input function. So anytime you see prompt the user, this here, prompt, user, meaning user will enter in values. That means use input. There's two ways to do it. Here's our first way at the top. That's the way you would type it if you were expecting numerical data. If you're expecting text, use the S as an additional option. Okay, moving forward, let's get to the disp function. So let's say I'm told to use the disp function. Disp is for display, to print out the following text given the user inputs from the input function section. So using the data in my program down here, I want to print out the results. So for a flow of fluid name, so here I'm entering in whatever the fluid name was, with a density of, enter in whatever my density was, and a velocity of this. The pressure drop across the enlargement as a function of the diameter ratio is, and then I print out a table. Okay, the input function is relatively straightforward. The display function is where we're starting to get a little more complicated. And once we get to fprintf, we'll get even more complicated. Okay, first things first, disp function. Disp stands for display. It's a function, so we type the name, open close parentheses. Inside of those parentheses, we can enter in one thing. One thing. One single variable, one single string of text. However, that string of text can be composed of other strings, and that variable can be composed of other variables, as long as we combine them into one. So if I want to just print out some text, display, semicolon, display is going to print out whatever is in here into my command window. So here you can see it printed out text here. Notice, though, display is going to print out letter for letter, character for character, print space out space text space here, and then automatically, behind the scenes, it inserts a new line. So if I did this, it's not going to read in those little characters that we saw, or that we're going to see in it with fprintf. There's less control over how to print things out with disp. It's literally just going to print out everything in here, line for, or letter for letter, character for character, followed by a new line. And there's less control, but it also means it's pretty simple to use. If you want to print out some text, you just enter in the text. If you want to print out a variable, you just enter in the variable. So there's automatically some default. If I left the semicolon off here, it automatically has some default printout in MATLAB, where it would print out the name of the variable, equal sign, and then print out the values. There's automatically some default printout for our variables in MATLAB when we leave the semicolon off. And that's really nice. That means MATLAB's a little bit easier to use than other languages. However, if we want to make it look nicer, if we want to clarify things and display things in a specific way, this is where we start to use disp and fprintf. So if I want to calculate del P and then nicely, or better, not better, but just print out, have a little more control over how I want things displayed, I can use disp. So here I'm going to print out just a single line of text followed by a new line. Here I'm going to print out all of the values inside of my variable. Notice it prints it out exactly the same as it printed it out before. It just takes off the variable name. And I can print it out transposed, so now I can better see my values. Even though I know it's stored as a row, I can print it out explicitly as a column. But no, it doesn't print out the name of the variable anymore. That's really useful when we are doing tables, and we'll see that in a minute. If I want to print out data and text combined, I'm going to create a new array. Okay, so let's go back to printing out this data here. Let's print out this first line. So to print out that first line, I'm going to use the display function. I'm going to create a new array because I'm going to combine some stuff. I'm going to have some text combined with some variable data. So that text looks like this. For a flow of, and now I'm going to insert some data. The data I'm going to insert is in my variable called type. And then I follow it by more text with a density of insert some data. That data is going to be stored in row, followed by more text. Kilograms, space kilograms, meter per meter cubed, and A. Hold on. Let me just move things around. There we go. See if that works. So display this array of text where print out characters FOR space A space FLOW space OF space, and then insert the values in this variable, and then continue printing out space WITH space A space DENSITY space OF space, and then print out the value in this variable. Space KG \m caret 3 space ANDA space, not space, A, end. It's going to insert a new line automatically. So let me run this. And here we can see what it printed out. It printed out for a flow of gasoline. Gasoline is the value stored in type. You can see that in my workspace. With a density of. The variable or the value stored in row. It printed out an X here. I'll tell you that in a minute. And then the text kilograms per meter cubed and A. Kilograms per meter cubed and A. So it printed out an X for row because row stores numbers. Row does not store text. Type stores text. Row does not. So it printed out type fine because type stored text. If we want to convert our text to, or we want to convert our numbers to text, we just use the num2string function. So there we go. I fixed it. So now it inserts that number because it converts that number to a string, to a text, so that it can insert and print out appropriately as opposed to just the X. So if you're inserting a variable that stores text, just type the variable. If you're inserting a variable that stores numbers, stores numerical data, use num2string. So this is where students start to get a little complicated. Understanding Disp. Let me show you what happens if I leave these brackets off. If I leave these brackets off, it gives me an error. It doesn't really tell you, it doesn't really give you much information with this error. However, remember, display can only print out one thing, one string of text or one variable, one array at a time. So since it's not one continuous string, since I'm combining this string with this variable, with this string, with this variable, with this string, I need my brackets. So that's a common error, forgetting your brackets. And then semicolon. So I am explicitly printing out this text with the value in this variable, with this text with the value in this variable, with this text. Okay, it automatically follows with a new line. So now let's print out my second sentence. I've printed out this first sentence. Check. Let's print out my second sentence. I'm printing out a new line, so I need disp, open close parentheses. This sentence is going to be text combined with some data. So I need open close brackets. Where first I'm printing out the text velocity of, and then I'm printing out some data. That data is going to be stored in a variable called v. And then I'm printing it out, printing out meters per second, comma, the pressure drop across the enlargement. So now it's going to print out velocity space OF space. It's going to print out this number stored in V. Remember, V stores a number, which means I need to convert that number to string, to text. So I use num to string. There's also int to string, but I encourage you guys to use num to string. So it prints out the number stored in V, and then follows by more text, space m \s, comma, space, etc. All the way across the enlargement. And then a new line. So now you can see here's where it prints out. For a flow of value with a density of value and a velocity of value, the pressure drop across the enlargement. If I changed those values, water 1, 0.3, now it's different for a flow of water instead of gasoline with a density of 1 instead of 735, with a velocity of 0.3 instead of 5. So now I can print out the values on the fly. Let's put this back. So then I've printed out that one. And then disp, print out my third line. This is only text, so I don't need a new array. However, you will not be penalized for it as a function of the diameter ratio is. Once again, these aren't needed, but you're not going to be penalized for them. So now here's my first line, here's my second line, here's my third line. So I've printed out all of this using 3 display functions. Note with display, you don't really have any control over how many digits this prints out, and this prints out for V and row. It's going to be a default. MATLAB's going to choose for you. Okay, now let's say I want to print out this table here. Print out this table. Once again, I can use display. So I need to print out this line, and then here's my numerical results from my calculations. So here's my diameter ratio in R, and here's my results in del P. So first things first, just print out my header. These 2 lines. Disp. Diameter. Pressure drop. Disp. Ratio. PA. Notice when you print it out, it prints it out character for character. So immediately it prints out diameter space pressure drop. Immediately it prints out ratio at PA. And that's fine, but if you want to space things out a little bit, notice this is spaced out here. This is spaced out here, it's indented. You just literally enter in spaces. Spaces, ratio, I want it to line up there. Pressure drop, maybe I want 2 spaces in between. Space that out. It literally prints it out space for space, character for character. And so if you ever have to align something, like text, just space it out manually. Go in, add a bunch of spaces, see how it looks, take those spaces out, see how it looks, try it again, see how it looks, etc. A lot of this is just try something, see what it looks like, adjust. Okay, so I've printed out this header, that one, and that one. Now, I want to print out this data here. So I could say disp R and just try that. So start with that for now. So display R. Notice R is displayed as a row because it is a row. If you look in my workspace, R is a 1x9, which means it's 1 row, 9 columns. So it prints it out as a row. If I don't want to print it out as a row and I want to print it out as a column, I just transpose it. So now I have this. So now we can see I'm starting to get what I want to look like. I have that first column of data here. I have that first column. Now I want to print out the second column. The second column are my calculations. So I could say disp del P. Let's see what this does. Okay, so this will print out R as a column. Immediately below that, it will print out del P as a row. Okay, so let's say I want del P to be as a column. There we go. Okay, so it stacks them on top of each other. I don't want them on top of each other. I want them next to each other. If you want variables to be printed out next to each other, you need to put them together into one array. So same thing that you did here. If we're trying to combine text with variables, we need a new array. If I'm trying to print out variables next to variables, I need a new array. In this array, I'm going to put R next to del P. So here I'm saying, print out the new array where R is placed next to del P. Now when I run it, we can see that R is placed next to del P. Keep in mind, you need to have those brackets. If you do not have them, it will give you an error because display can only print out one thing at a time. So you need those brackets. There we go. So using the display function, I've printed out these 3 lines of text where I've inserted the value in type, inserted the value from row, inserted the value from V, and then I've printed out a table of my R values next to my pressure values. So when you guys do it, it might look something like this. Like I said, we don't really have control over how display prints out our numerical numbers. The way we can control this is using format. So, Josh, that's a good question. So remember, you just gotta play with it. So, like I said, manually align things. So I know that my header should be pressure drop, and I know I should insert the units. So it lines up like this. So you just line it up manually. So you print out, okay, it looks like that. Okay, I want to space diameter over like 3, place ratio over 3. See what that looks like. Okay, diameter is kind of above it. Pressure drop, maybe I want to space it over a couple bit more. Run that, see how that aligns. Maybe diameter over pressure drop. See what that looks like. Okay, I've got my first one spaced out. Let's space out my units. So the nice thing about the font that is used for programming, it's called Courier New, is that every character takes up the same amount of space. So one space here is automatically going to align with one character above it. So if I'm trying to space out ratio and PA, and I know this is where diameter and pressure drop are going to be, I can just space it over, be like, okay, I want it to be here, and I want it to be here. If it looks like this in my code, it will look exactly like that when it's printed out. Okay, So to control numbers using display, we can use the format function. And I mentioned this a little bit, but you can see here that it's printed out like this. I don't like that. So you might want to use format short G. Format short G is going to alter the way that numbers are printed out. It's going to not choose scientific notation as its default. It's going to print out each number independently using the shorter of the two, either scientific notation or regular. So now when I run it, we can see my numbers are adjusted. And now we can see my header isn't printed out the way I want it to, so I'll just space it over. Just keep going, run it, see what that looks like. Maybe one more, run it. Maybe this is over too far, run it. So you just go through and adjust it space by space. That's just how it works. A little too far. There we go, I like that one. Okay, so Joey says, so can we use these functions to organize? Yes, so this is how you would print out your data to the command window. You can always see your data in the workspace, but sometimes it's just nicer to print things out. I like to use display and fprintf for debugging purposes, specifically when we get to loops and more complicated code. Okay, that is all we have time for today. It took a little bit longer than I wanted, but that's fine. We did a lot of review this morning. We did more review than I thought. But we're gonna stop there. I have office hours to go to. We will talk about fprintf and load and save on Wednesday. And then depending on whether or not we have time, I have one more example. If we don't have time to go over that example on Wednesday, I can also create a new video for you guys to watch as extra help. Okay, that's it. Any final questions before we log off and I transition over to Zoom? Totally forgot my headphones today. Whoops. Okay. With that, it depends on your belief system. I personally believe the chicken came first. It's a very good question, though. I really think that's a real good question. Okay, I will see you guys on Wednesday. Have a wonderful day. Get everything done. You can do it. I believe in you.